Welcome back, students. Students, in the previous module we have discussed about elementary row or column operations, and I have told you the different steps to be followed and the different operations to be done in case of elementary row operation. But children, if we start with the topic determinant and using the, you can say, properties of determinant, the elementary row operation can be done in a very simple way, because the base for the elementary row operation is to get the inverse of a matrix, and with the help of the determinant we can get the inverse of a matrix in a very simple way. So first of all, we should understand what is the meaning of the term determinant. So here I have written one definition for you people. To every square matrix, A means Aij, you can means you know that Ij stands for the position of the respective row and column of order n, and you can say the all elements of you matrix A belongs to real number. We can associate a unique real number called as determinant. That means, if in another way, in a simple way, you can say that the magnitude which is assigned to any matrix is basically called its determinant, and if the matrix is denoted by A, the determinant of the matrix will be denoted by the symbol which is called as what? Mod of A. Am I clear, all of you? Now here I'll give you one example. Let us consider a matrix, I'll say square matrix of order 1 by 1. That means one row and one column. So here I have written a matrix A, and this is only A. That means it is comprising of only one row and one column. So if the determinant of this matrix has to be taken, the value of this will be equals to A. So that's a very simple thing for what matrix? Tell me. Square matrix. So this is the magnitude or the real number which has been associated to this particular matrix, and this has been given the name as determinant. But if we'll take a matrix of order 2 by 2, so let us consider a square matrix of order 2 by 2. So I'm assuming it as, let A be the square matrix, and the positions of the elements I am writing A11, this is first row first column, A first row second column, A second row first column, and A second row second column. So if the means, you can say, determinant of this matrix needs to be calculated, how to do means go with that. So in that case I'll write here determinant of A will be equals to, I will write this element, what is this? A11. So I'll write here A11, and the magnitude of this is A22, minus, I will write here A12, and the magnitude of A21. It will be very clear in the next, you can say, example, how to find the, you can say, magnitude of any matrix and relate it to determinant. Like take the example here, A is equals to 5, 4, 7 and 8. And if I have to find the value of the determinant of this matrix, the value will be equals to what? Simply I am going to cross multiply. That means 5 into determinant of 8 minus 4 into determinant of 7. And as we have already studied, that if a single matrix element is there in the, you can say, matrix, that means it is of 1 by 1. That means whatever the element, same will be the value of the determinant. So that will be equals to 5 into 8 minus 4 into 7. So 5 8 the 40 and 7 4 the 28. So the value of the determinant is equals to 12 right here. Am I clear, all of you? So this is how you can easily calculate the, you can say, determinant of any square matrix. That's a very simple thing. And now a few very important thing I want to tell you here, children. Like each of the element has got its own position. Like if I am writing A11, that means it belongs to the first row and first column, and with the help of this position we can simply find out the minor as well as the cofactor also. So here we have to study about one very important thing, which is basically called as what? Minor and cofactor. So what do you mean by the term minor? First of all, you should understand. Like suppose I have been given a matrix here, A is equals to, I am writing the same example, A11, A12, A21 and A22. So suppose if I have to find the minor of A11. That means the minor of which element has to be calculated. We are going to omit the row and the column of that element with which it is associated. That means if I have to find the minor of A11, that means A11 belongs to this row as well as this column, so that will be omitted. So what will be left? That will be the minor. So the value will be equals to what? A22. This will be the minor of A11. Am I clear or not? Suppose if I have to calculate the minor of A12, that means I have to find the minor of this one. So A12 is lying in this row and this column, so that will be omitted. So what will be the minor of this? It will be A21. Suppose if I have to calculate the minor of A21, so A21 is this one, so this row and this column will be omitted, so the value will be this row and this column, so the value will be equals to A12. And if I have to calculate the minor of A22, that means the last row and this column will be omitted, so the value of this will be equals to A11. So this is how for each and every element of the matrix we can calculate its minor. Now next we have to deal with the cofactors. So